Hello, good morning viewers. In this tutorial, we are going to learn the simplest way to add or subtract polynomials. You see, we have 8 questions here. All right, let's start with the first one. In the first question, we want to add this polynomial to this polynomial. So let me show you how to arrange them. First of all, we are going to begin with a polynomial with the highest degree. All right, so the first polynomial is negative 7 x squared. You have to arrange them in order. Then the second term will be 2x, so we have plus 2x, and the last one is the constant, which is 14. Then we bring this one to the bottom. The highest here is negative 5x squared, so we bring it here, negative 5x squared, followed by positive 10x. Then the constant, which is 7. Draw a line. Remember, we are adding. Start from the left hand side. If you add negative 7 to negative 5, you are going to obtain negative 12. So this becomes negative 12x squared. Then the second terms, we have 2 and 10, which is 12 plus 12x. And lastly, our constants are 14 and 7, making 21 plus 21. So we have just added these two polynomials. Let's move on to the second question. The second question, we want to add this polynomial to this. Let us detect the polynomial with the highest degree. They both have degree of 5. So it doesn't matter. We can start with either one. Let me start with the first one. We have to start with the leading term, which is negative 3a to the power of 5, negative 3a to the power of 5, followed by the power of 4, negative a to the power of 4, then power of 3, which is negative 9a to the power of 3, followed by 2, which is negative a to the power of 2, followed by 1, which is negative a. We don't have any constant. All right, let us take the second one. The highest power here is negative a to the power of 5, so we are going to bring it here, negative a to the power of 5, followed by negative 6a to the power of 4, followed by negative a to the power of 3, then followed by negative 3 a to the power of 2, then followed by negative a. Remember, we are adding. We start from the left hand side. Negative 3, negative 1 is negative 4, so we have negative 4 a to the power of 5. The second one is negative 1, negative 6, which is negative 7 a to the power of 4. All you have to do is to add their coefficients. Then negative 9, negative 1 is negative 10 a to the power of 3. Then negative 1, negative 3 is negative 4 a to the power of 2. Then last one, negative 1, negative 1 is negative 2 a. So we have just added this. Let's move on to question number 3. The first polynomial has a degree of 4, while the second polynomial has a degree of 5. So let us begin with the second polynomial. We have 19n to the power of 5, which is the leading term, followed by this, which is plus 3n to the power of 4, then followed by this, which is 2n to the power of 3, followed by this, which is 6n to the power of 2. Then last one, we have plus n. Then we add the first polynomial here. We have to start with this one. You place it under 3n to the power of 4. So we have 33n to the power of 4. Then followed by this one, we have plus 10n to the power of 3. Then lastly, we have 7n to the power of 2. This is how to add, but if you like, you can complete the rest. You can add 0 here. And here we have 0n to the power of 5. So let's add from the left hand side to the right hand side. We have 19 plus 0 is still 19. N to the power of 5. Then plus 3 plus 33 is 36. N to the power of 4. 2 and 10 is 12. N to the power of 3. 6 and 7 is 13. N to the power of 2. 1 and 0 is 1, so we have n. And this is said to be the solution to this problem. Let's move on to question number 4. The first polynomial has a degree of 6, while the second polynomial has a degree of 4. So let's start with the first polynomial. And we have to arrange it in order. We have to start with the highest power. So we have c to the power of 6, followed by 11, c to the power of 5, then followed by negative 4, c to the power of 4, followed by, we don't have a power of 3, so you can call it 0, c to the power of 3, then followed by 3, c to the power of 2, followed by this, we have negative 25 c. We don't have constant. Then you bring the other one, the highest power here, I think we can see it is 4. So under 4, we have negative 2c to the power of 4. Then the power of 3 is negative 7c to the power of 3. Then followed by 15c, which has a power of 1. You have to bring it under the power of 1, 15c. Then you can complete this by adding 0c to the second power. Let's add. You can also complete this as 0c to the power of 5, 0c to the power of 6. If we add from the left to the right, we have the coefficient here is 1, while this one is 0. So we have 1 plus 0 is 1, which is just c to the power of 6. 11 plus 0 is 11, c to the power of 5. Then negative 4, negative 2 is negative 6, c to the power of 4. 0 plus negative 7 is negative 7, c to the power of 3. 3 and 0 is 3, c to the power of 2. Then negative 25c plus 15c will give us negative 10c. So we have just added these two polynomials. Then question number 5. We have two polynomials as well. This one has a degree of 6. This also has a degree of 6. So it doesn't matter. We can start with any one of them. So let me begin with the first polynomial. We have to write them in order. We have negative 8 m to the power of 6, followed by this plus 9 m to the power of 5. Then we don't have a power of 4, therefore we can write 0 m to the power of 4. We don't have a power of 3 as well. We can write 0 m to the power of 3. But we have a power of 2, which is negative 5 m to the power of 2. Then we have m plus m. Then lastly, we have our constant, minus 4. Then we bring this one. We have to start with 8 m to the power of 6. So we have 8 m to the power of 6, followed by negative 9m to the power of 5, negative 9m to the power of 5. We don't have a power of 4 as well, so we can write 0 m to the power of 4. We don't have power of 3 as well, 0 m to the power of 3. We don't have a power of 2, plus 0 m to the power of 2, but we have a power of 1, which is negative m. Then lastly, we have our constant, which is positive 4. So this is what we need to add. If we start adding from the left hand side, what you can see here is negative 8, positive 8. That will make them 0. So we can just discard them. We don't have anything here. Also, we have positive 9 plus negative 9 is 0. These are gone as well. 0, 0, nothing. This is also nothing. Let me skip this for now, because you can see this and this will cancel as well. They will cancel. This will also cancel. So the only result we have here is negative 5m squared, because plus 0 will not change it. So the whole of this will just give us negative 5m to the power of 2. This is our solution. Then let's take the other one, which is question number 6. Our first polynomial is of degree 4. So let's start with negative 16p to the power of 4. Negative 16p to the power of 4. Then plus 4p to the power of 3. Negative 24p to the power of 2. Plus 8p. We don't have constant. Then the other one, we have p, then followed by 0p to the power of 3, then plus 23p to the second power, then negative 2p. We are adding. To the left, we have negative 16, positive 1 is negative 15. P to the power of 4. Okay, remember this has a power of 4. Then 4 and 0 is 4. So we have 4p to the third power. Negative 24 plus 23 is negative 1. So we have negative p to the second power. Then lastly, we have 8 plus negative 2 is positive 6p. And this is our solution. Then the second to the last question, we have two polynomials here. The first polynomial has a degree of 4, while the second one has also a degree of 4. So we can start with either one. So we have negative z to the power of 4 plus 2z to the power of 3 plus 0 z to the power of 2. Then plus 35z. We have our constant, which is 6. Then the second polynomial, if we bring this one z to the power of 4, z to the power of 4, then this one negative 25 z to the power of 3, then we have 2 z to the power of 2. Then 1, do we have? Yeah. Plus 3. Z, then constant, which is negative 5. We add. To the left, we have negative z, positive z. That will give us 0. So we are going to discard this one. Then the second term, we have 2 plus negative 25. That will give us negative 23. So we have negative 23 z to the power of 3. Then 0 and 2 is 2. Z to the power of 2. Then here we have 35 and 3 is 38. 38 z. The last one, 6 plus negative 5 is positive 1. So we have plus 1. So we have just added these polynomials. Then the last one, both polynomials have degree of 3. So we can start with the first one. It doesn't matter. We have the highest power is d to the power of 3. So we have 5d to the power of 3. Then plus 10 d to the power of 2. Then minus 2d. Then the constant is negative 8. Then the other polynomial, we have negative 5d to the power of 3. then followed by negative 10 d to the second power. Then we have plus 5d. Then our constant is positive 28. To the left hand side, positive 5 and negative 5 will turn this to 0. So we are going to discard this. We are going to discard this as well. So all we have are the last two terms. Negative 2 plus 5 will give us positive 3, positive 3d. Negative 8 plus 28 will give us 20. So we have plus 20. So this is our solution. And we have our answers here. You can go through them. So here comes to the end of this tutorial. But some of you might ask, what about subtraction? Subtraction is very simple. Let me take one example to demonstrate subtraction. Suppose we want to subtract this from this. Let me show you how you can do that. Instead of addition here, we have subtraction, right? Let me clean the answer. The best way to do that is to distribute this negative sign onto all of these 3 times, no matter how many times they are. After distribution, then you turn this negative sign to positive sign. So let's do that. If you distribute negative to this, it will become positive. Distribute negative to positive, it will become negative. Distribute negative to this positive, it will become negative. Then you transform this to addition. And that's all. Then we start from the left. Negative 7, positive 5, that will give us negative 2, x to the second power. Then 2, negative 10 is negative 8, x. Then 14 plus negative 7 will give us positive 7. Can you see the difference? All you have to do is to distribute that negative sign onto all the terms in that polynomial you wish to subtract. Then all the signs will change. If it is negative, it will turn to positive. If it is positive, it will turn to negative. Then you add and you are good to go. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.